Good morning, participants. I once again welcome you for the today's second session of the FDP Series 1. And for this session, we have the guest speaker, Dr.P.T. Ravichandran, Professor from Department of Civil Engineering, Katangatur campus of SRM Institute of Science and Technology. And he did his B Civil Engineering from Madurai Cambridge University and ME and PhD from College of Engineering, Indi. And his specialization is from geotechnical engineering. And also his research interest includes ground improvement, geotechnical engineering, biotech, building material, pavement, concrete. In addition to this, he has n number of publications in both national and international forums. So I welcome you all for this session, and on behalf of you, I once again welcome Dr. P.T. Ravichandran sir for this session. Over to you, sir. Please take up the session.
Thank you, Mr. Edil Kumar, for a nice introduction. I will share the screen now.
Yes, sir, please, sir.
A very warm good morning to all the participants from the various colleges and few from the industries, as well as the research scholars. So in this pandemic situation, we are not in the position to meet each and everyone in person. So the program organized by the Krishna Institute offering this through online. First of all, it's my pleasure to express my sincere thanks to the organizers giving the opportunity to share the knowledge to our faculty members as well as the research scholars and the industry people. With this, today, I'm going to just look over the lightly loaded structures and expansive soil problem and the remedial measures. So the participants may be in a wide variety, knowing some of the things in what is expansive soil, how to identify up to some extent, or some of the people may be on more. So the mixed mode, I'm going to concentrate the first expansive soil, how to identify in a earlier way. Now how we are recently looking over this and how we are going to be concentrating the problems with the remedial measures. So if you are generally taking the elements, if you're taking the 12,500 kilometer diameter of the earth, on the top that 8 to 35 kilometer is the crust. So coming to here as a expansive soil, I say the components of the soil as oxygen, silica, alumina is around 82.4 as a geotechnical engineer, because in a civil engineering we are concentrating the superstructure as well as the substructure. So whatever the structure we designed as a superstructure to withstand, we need to concentrate about the subsoil conditions to place the superstructure over the substructure. So the 82% of the elements which is mainly contribute the strength in the soil to carry the structures. So what is the expansive soil? Generally say there is a swell in a considerable amount because of the absorption of water from outside, and it may sink after the removal of the water due to evaporation or some other causes. These phenomena is maximum in clay soil except sandy soil, but it exhibit a very high degree in case of certain clay soils. Hence, such soils are called the expansive soil. The soil is one of the most problematic in geotechnical engineers.
Sir, sorry to interrupt.
Yes.
Are you moving your slides, because we don't see the movement of slides?
Slide is not moved?
No, sir, because I think you have shared your PPT in the editable mode.
No?
No, sir, we cannot see that presentation. I think the sharing you have to
You will come on now.
Sir, I can see the editable mode of PPT, sir, but the presentation mode I cannot see, sir.
Now it is in a presentation mode for me.
Yes, sir, but you would have shared the PPT, I think, the window of PPT in editable mode.
But for me it is in fully in a sharing.
Sir, I think you can share the screen in the option Google Meet.
Share the screen only I am given. It's okay.
Yes, sir. Now it is okay, sir. Fine, sir.
Okay.
Thank you, sir.
Now it's okay, no? Screen is moving.
Yes, sir. Yes, sir. I can see the presentation mode and it is moving.
Okay.
Thank you.
Okay, thank you. Thank you. Sorry for the disturbance. So in this, mainly we concentrate, I think earlier you have not seen, so I shown the slide. So the 8 to 35 kilometer of the crust, out of which the 12,500 kilometer of the diameter of the earth, the maximum elements is the silica, alumina, and oxygen. Here only we play a role in geotechnical engineers. So the expansive soil, as I said, it is a considerable amount of the absorption of water from outside and sink after removal of water, except sandy soil. The expansive soil is the most problematic soil for the geotechnical engineers among the more problematic soils. It is not a problem only for our country or our state. It is a worldwide problem. The parent material associated with the soils are maybe the igneous or sedimentary rock. Totally the 6 natural hazards, maybe the earthquake, landslide, hurricane, tornado, flood, and expansive soil. Considering the problem, next to the hurricane windstorm, it plays a second place among all the natural hazards. In case of America, the most destructive natural hazards is due to the expansive soil. The loss is more in buildings. So in our country, it covers nearly 3 lakh square kilometer, covering all the states over Maharashtra, Madhya Pradesh, Karnataka, Andhra, Tamil Nadu, Uttar Pradesh. The primary bedrock is the basalt or the trap. Considering the minerals, the expansive soil in nature, it is because of presence of non-malonite and illite, which are highly responsible for the excessive swelling and the shrinkage characteristics of the soil. So if you're going to consider when the soils may expand. So if you're going to this increasing depth with the increasing the moisture content, about the moisture content, it is to be taking that in 3 categories. One is the equilibrium moisture content on covered area, uncovered natural condition, and the seasonal variations. All the cases are to be considered. While you are going to be considered all the cases, the water table is varying up to certain extent up to this stable zone. So here, above the stable zone, by considering all the cases, there is a fluctuations in water table. So this problem is in the above the stable zone. That is so that it is called the unstable zone. So if you are going to be, if we are placing the foundation in the unstable zone, we are going to taking more care. If you are going to be placing the foundation below the stable zone, there is no problem is occur. However, over the foundation, the elements which is to be